So for number 1, domain was all real numbers. It should be left to right, so negative infinity, positive infinity. Range was starting at -3, but bracket to infinity. So if you had a parenthesis there, that was incorrect. Domain for this one was all real numbers. And the range for this one starts at negative infinity and goes to positive 4 with a bracket. Questions on those first two? Make sure you are fixing any mistakes that you may have or may not get. For this one, I can see this clearly here, but you may or may not have seen this on the graph, and that's okay. So for increasing, that should have been starting from this point and ending at this point, so -3 to +7, I'm sorry, x values. -3 to 3. Those are both included points, so brackets. These are only your x values, and you should be reading left to right. Decreasing was from -7 to -3. I accepted a few things for constant. If you put NA because you couldn't see this line, that was fine. There was an actual constant piece from 3 to 8. But if you put NA, none, that was fine too. Leaving it blank though is not. Questions on that one? Then you had to write these in interval notation and set builder notation. This was less than -5, so negative infinity to -5 with a bracket. The next one was negative infinity to +4 with a parenthesis. And the last one starts at 1 with a parenthesis and goes to infinity. Yes, got it. And then set builder notation. All of these should have started with curly brackets, x in this line, or y, either or. And then -4 to infinity would be x is greater than or equal to -4. These are between two numbers, so it's still going to start off the same way. These are both included, so that should be -7 is less than or equal to x, which is less than or equal to 3. And then similarly for the last one, but just less than, not less than or equal to. Questions on any of those? Anyone still need this page? On the next page, objective 2, you needed to have the correct parent function and all of the transformations stated. So translated 3 units down was an outside thing, left was inside, so this would be f of x equals, or if you put y equals, that was also fine. X plus 2 on the inside, make sure you have a square on the outside, minus 3. Second one, translated 5 units up, was outside, reflected across the y-axis is doing this. So that's a horizontal transformation, so that's inside. So you would have negative x inside parentheses, square on the outside, plus 5 on the outside as well. Some of you, when you got to the absolute value, were still putting the square, and that's not the parent function, so make sure you have just the parent function. Reflected over the x-axis is doing this, so that's a vertical reflection, so that would be on the outside. To the right is inside, so we have f of x equals the absolute value of x minus 12 with a negative on the outside. And the last one, stretch vertically by a scale of 5, that's outside, and you're just multiplying it by 5. Reflected across the y-axis, if we look back, that was an inside thing, and then translated 2 units down is an outside thing. You should have 3 things for this one. 5 on the outside, negative x on the inside, minus 2 on the outside. So for these, each transformation was worth 1 point. However, if you put the wrong parent function or something like that, then that also deducted points. Yes. Say that one more.
Can you spell number 4?
Number 4. So the stretch vertically by a scale of 5. Vertically is an outside function. So you would take that 5 and put it on the outside. Reflected across the y-axis, you may have to visually remember what that's doing. See, that's doing this. So it's a vertical thing. I'm sorry. I said x-axis. I was doing x-axis, but I meant y-axis. That's a horizontal thing. Horizontal things are inside. And then translated 2 units down. Down is a vertical thing, so that would also be on the outside. So that would do exactly what you think it's going to do. The negative would go in front of the x, and 5 would go on the outside.
So, if it's to the right, it's a little square.
To the right is always opposite. So right is minus and left is plus.
I'm at the bracket.
Oh, that's because of this.
But like, what I'm talking about is what you see it.
Because this one was squared. You're talking about this compared to this. That's why this has the line, so this has a square.
Like, I'm going like the 2. You see the 2 in the 12. Why is it 12? That's what.
Why is it 12 and what? Just because it's inside. It's going to the right, it's horizontal. So anything horizontal goes inside.
And if it was to the left, is it?
It would also be inside.
Oh, okay.
Any other questions on those 4? Objective 3, you had to write the correct equation for each graph. There were 4 transformations that happened to the first one and 3 transformations that happened to the third. You did not need to list out those transformations, but if it helped you, that you could do that. So 1, this flipped over the x-axis. This stretched by a scale of 2. So remember, you can always draw your parent function, compare to see if they're the same, if they're different. This was moved to the left 1 and up 8. So putting all those together, you have f of x equals, this isn't a quadratic function, so you need something that's x squared. We have our negative first. then our scale, then in parentheses our left, which would be plus. Outside of the parentheses our square, and then also our plus 8. So you got a point for each correct transformation. For this one, this was our absolute value function. This moved to the right 3, down 2, and the scale was also 2. So putting all of those together, we have f of x equals, our scale would come first, then our absolute value sign, our right inside, and our down on the outside. So that one was worth 3 points.
Is there always a scale for these ones?
Not always, it just depends. So this one we know there's a scale because this distance is 2 and not 1. This one we know there's a scale because this, when you count the slope, this is 2 and not 1. Looking for slope in the scale, yeah. Well, for absolute value. For the quadratic, you have to kind of look at the difference. Other questions on those two? For objective 4, you have to describe the transformations. These had to be very specific, using the words translate, reflect, vertical stretch or vertical compression, reflect over the x-axis or y-axis. If you just said reflect x-axis, I don't know if you're talking about it's reflecting over or it's reflecting with the x value. I don't really know what that means. So be very specific. This one had 2. Both were translate. One was inside, so that has to be left or right. It's plus, so it would be opposite of what you think, so that would be left. And then on the outside, that would be vertical, and it does exactly what you think, so down. And each of those were worth 1 point. If you put moved or shifted, that wasn't the word I was looking for, so you got off some points. If you just put left 1 unit or left 1 or down, you were missing what it actually did. So you also missed points there. The second one had 3 transformations. Some of you were combining these two together. Those are 2 separate things. So you need a reflection and a scale. This is on the outside, so that should be a vertical thing. And it's a fraction, so that should be a compression, not a stretch. Many of you put stretch. Does not matter the order, but we had reflect. We had a vertical compression. I'm not finished with this, I'm just starting them. And a translate. So reflect, it's on the outside, so that would be vertical reflection over the x-axis. Vertical compression by a scale of 1/2. And translate on the inside, that would have to go to the right. And each of those were worth 1 point as well. What questions do we have on that section? Then the last section, you needed 2 things on each of these, or on both of these. Your vertex and your graph. Graph correctly. Your vertex, look at your inside number and your outside number. Inside number does the opposite. This is really moving left, so that would be at -1. Outside number does exactly what it's supposed to. So you would start at that point, -1, -4. Look back at your function to see if there was any scale changes or if it reflected. In this case, it did not. So you would just go up 1 to the right one and up 1 to the left one. At least 5 times. You could have went more than that. Or at least to have 5 points, but you could have went more than that. And then the second one was similar. Look at the inside number and the outside number. This is +1, so this would be a -1. It's the opposite. And then on the outside, +3. This, going back to the function, has a negative on the outside, so it's flipping upside down. So your parent function, it would look like the parent function, but just flipped upside down. So you would go down 1 to the right one and down 1 to the left one. And then out, right, and left 2 and down to 4. And it should look something like this. Some of you went past that, and that was fine. You only needed 5. What questions do we have on that section? So tomorrow, you'll be taking your 8.1 and 8.5. So that'll be this and the domain range notation. So make sure you are practicing at least those 2, and then make sure you practice the other stuff too, because we'll take 8.1, 8.5 tomorrow, and then 8.2 through 4 Wednesday. Yeah. So for the remainder of class, you can practice, review. If you did not do your Khan Academies over the weekend, you can work on those. If you didn't do previous Khan Academies, you can do those. When you look at your grades, you'll see that these quizzes are not in, but I wrote all of your scores down. I was having issues with the grade book, but they will go in hopefully today.